going to take a look at some of the problems in this first link. We'll run out of time for a 5-minute video. This first one is pretty straightforward. I'm not even sure you need help with this one. The antiderivative, raise the exponent by 1, multiply by the reciprocal of the new exponent, evaluate from 2 to 5. And so I like to show my work like this. I'm going to put 5 in for x and get 125 over 3. Minus, put 2 in for x, I'm going to get 8/3. And I'll let you take it from there. For this one, this is supposed to be 2 sine of 2x. I'd be thinking about using U-Substitution. Let u equal 2x. And so therefore du equals 2 dx. And I can see right here that I've got a 2 and a dx right there. So I'm going to replace the 2 dx with du. And the sine of the 2x I'm going to replace with u. And I'm going to replace the limits of integration. When x is 0, 2 times 0 is 0, so u is still 0. When x is pi over 2, picture putting pi over 2 in for this x. 2 times pi over 2 is pi. So I can go like this. And now the antiderivative of sine is what? Negative cosine. Evaluated from 0 to pi. And well, I'll let you take it from there. Well, maybe I'll do a couple steps here. So I've got minus cosine of pi minus cosine of 0. And this is cosine of pi is -1, cosine of 0 is 1. I'll let you do the substitution and figure that out. For this third one, just pretend you were doing this problem right here. You'd probably use U-Substitution. You'd say let u equal x cubed minus 1. Then du equals 3x squared dx. And that's what we've got here, 3x squared dx. So I'm ready to rewrite this as 3x squared dx gets replaced with du. And I've got the square root of u. The only question is, what will the new limits of integration be? Well, here's our formula for u. When x is 2, 2 cubed is 8, 8 minus 1 is 7. And when x is 4, 4 cubed is 64, 64 minus 1 is 63. So that's the answer to the question, determine the values of a and b. They didn't ask you to actually evaluate the integral. I'm going to skip this one for a second. We'll come down to this one. I'll just give you a suggestion. My immediate observation is that if I let u equal the sine of 2x, that du will be the cosine of 2x. But then I have to apply the chain rule and multiply by the derivative of the inside, which would be times 2, but I'll put the 2 out front. And there I've got a 2 and a cosine of 2x. So I can start rewriting this last one as, leave those limits of integration off for a second. 2 cosine 2x is du. And I've got the sine of, whoops. Yeah, I've got the sine of 2x is just u. So I'm down to u du. Question is, what are these new limits of integration? Okay. When x is pi over 4, put pi over 4 in for x. Evaluate the sign of that value. Put that here, and same for the upper limit. I'll let you take that away. And then I'm just quickly going to make an observation about this one. If this was the integral, the derivative with respect to t of 0 to t, I'll go ahead and go with t cubed of sine of x squared dx. The derivative would be, I would put t cubed in for x. And this is all the parameter to the sine function. But then I'd have to multiply by the derivative of the inside, the thing that I just substituted for x, which would be 3t squared. So I'm not going to take that to conclusion. I'm hoping you have an answer key and you can, this gives you the idea. Okay? End of video.